So as we said, this course is about fundamental of communication system. So today's topic is an introduction to electronic communication, and this goes to your learning outcome number 1. And this will be our reference book, chapter 1 of Frenzel book. So, okay, this is, as we said, introduction to electronic communication. We have these topics: significance of human communication, communication systems, types of electronic communication, multiplexing and modulation. So probably this is for our first today class. And next week we will talk about the electromagnetic spectrum, the bandwidth, and we have a short survey about the communication applications. But the last topic is not covered in our syllabuses. So yeah, so why communication is significant in our, for humans. We as human, of course, we are doing communication. Now, between me and you, there is going some communication. So I'm giving you a lecture, you are listening, and this is from remote. So you are very far from here, and this communication was exist from maybe beginning when human exist. Because if human want to communicate together, talk to each other, they need to communicate. So, and there are some barriers, mainly our languages and distance. So language, we talk about, every nations or regions, they have different language. So that could be one, or distance. So the distance, we talk about the early time, people couldn't communicate together, because if you were living in two different countries or different cities, you couldn't talk to each other because there was no any communication facilities. You only could talk to people next to you or around you. So, but people use different tools. They could write a letter, they could use some other tools to inform other people, even in a city or a region. If they wanted to talk each other, they could use different method to produce maybe a large sound or a light, so that people can see and understand. So this was communication, very old time. People later send letters by post or by train. So, but today communication is become very easy. We can have multimedia communication with even very far distance, which our mobile today do everything. So you can text, you can have video, you can have voice. So this is, we call it multimedia. So the communication, face-to-face, signal, written word, letters, all these are communication. So telephony, radio, so television, internet, all these are communication. It could be single media, it could be multimedia. Listening to music also is a communication. So yeah, today's we cannot continue our today's life without having communication, because all our business, all our life has been tied with communication today. So the basic component in a communication system, so very basic one is transmitter, channel, receiver. So, but transmitter need to first have a message, a signal. So, for example, my voice is the message or signal. It goes to, from my microphone, it will be converted to an electrical signal, and then that electrical signal will be transmitted from a channel. It comes all the way to Philippines now. So then from your speaker, it will be converted back to a voice, and the wave coming out, which is a voice wave, is also a form of electromagnetic wave or sound waves come to your ear. So that is we are now doing. In between, there could be different types of channels or media. Could be optical communication, could be satellite communication, or microwave. We have no idea. But I guess most of them going from optical communication, optical channels. Then this is a schematic showing the communication system. The information is audio, video, computer data going to, this is first need to be converted or make in electrical form or optical form. We have two forms today, either electrical or optical. Both can be then transmitted using a transmitter. Then it goes to communication system. We have noise in all communication system. There is no communication system which there is, without noise. Even optical communication, which is relatively the most perfect communication media today, but we still have some other type of noise. Each channel have different noise. The noise here may be referred to all unwanted signals. Can be distortion, can be, for example, thermal noise, it can be dispersion. So we will have in our channel, even at the transmitter side, at the receiver side, at those electronic devices converting the signals, some noise could be introduced. Amplifiers especially also amplify the noises and maybe induce a little bit noises in the system as well. So all those available. And at the receiver side, the signal supposed to be converted back to original type and show to the receiver. So receiver could be human, can be a computer, can be a television, radio, or many more. So here I am showing, maybe it's a little bit too early, but I believe you can understand as a third year of students. So the first figure, or the A, is showing you a nice and pure digital signal, which is, you can see the sharp edges. Of course, this is just in theories, but in practice, we may never have such a very sharp but we might have, but not always. So as soon as you send such a nice signal to a channel, the channel, after few meters or 100 or kilometers, your signal will be changed the shape. So this is receive signal without any noise happen, and then the next signal is some noise. Is not clearly shown the noise, and then at the end of receiver, we supposed to regenerate the signal to become like D, nice or similar to what we have transmitted. So that is, and we assume there is no error. But if there is error, which sometimes could be happen, the system need to resend the packet or the message. Okay, we will discuss these topics in the next chapters. So today is just we touch a little bit and introduce you the topics. Then in the next chapters, we go details of them. So what is message? So the first step in sending a message is to convert it into electronic or electrical form suitable for transmission. As I said, either electrical or optical form. What is message? The message is our voice, your computer data, your mobile data, image, videos, photos, all those are messages. There are many types of them, depend on from where to where. So maybe from one satellite to another satellite. So the first satellite, which is the transmitter, need to produce a suitable, message to send. Of course, the message maybe come from elsewhere. They transmit to another satellite. So they also have their own transmission system and their own format of communication. From each part of a communication system, the format could be different. So what is message? We have, for example, voice message, where a microphone convert our voice to electrical signal. We have TV, a camera record. So now there is a camera on my laptop recording the video and my voice is recording by a microphone. Both of them convert to electrical form and send in the form of digital packets to your place. So in computer systems, message is typed on a keyboard and converted to binary codes that can be stored in memory or transmitted. So yeah, I can write something, save in the computer, or like today what I am doing, right away send to you. So these devices, some of these devices we use to convert a message to electrical or optical form, we call it transducer. So transducers convert physical characteristics like temperature, pressure, light intensity, voice, and other things into electrical signals. So then the signal now is in electrical form. It goes to transmitter, and transmitter job is to collect of electronic components or signal and there are circuits that convert the electrical signal into a signal suitable for transmission. So then it will send to the media or channel, which could be electrical, can be optical, can be microwave, or other forms. So transmitters are made of oscillators, amplifiers, tune circuits, filters, modulators, frequency mixers, synthesizers, and other components. So depend on what type of communication system we have. So here I just show you a simple amplitude modulation or modulator. So this is a circuit. So just be aware, this is not my design. It's just I got from internet. I just wanted to show you what is a modulator or transmitter. Is not something very complicated. It's just few electrical elements or electronics elements. So you may have few resistors, maybe a diode or transistors, capacitors. Those few elements joined together, they can make a transmitter. So at one part, you input your message. In another input, you have your carrier, and then the two will be combined, and then they will be in a form of another wave with higher frequency, which is similar to your carrier, and they will be transmitted. This is just for your understanding. It's not a design, okay? Then what is a channel? After we transmit, of course, the signal goes to communication channel. Communication channel is a medium, or sometimes we call it media, by which electronic signal is sent from one place to another. It can be also optical. It's not only electrical. Different medias could be electrical, as I said, optical, free space, and maybe even some special medias. I just show you a few photos or images for your understanding. So in electrical media means wires. The wires could be coaxial cables. There are different types of them for different application. So I just show you for your understanding to see it's not just one type of coaxial cable. There are several types, and they mainly use for antennas and sending short distance signals. Today, we don't have long communication today with wires. It almost not exist. For short lengths, few hundreds of meters or few tens of meters. These days, we use wires. This could be coaxial cable for television, or even can be for sending some other type of communication. For internet or computer, we mainly use twisted cables or wires. This can be from your computer to your, to network, your communication network. So you usually use this Ethernet, plug. So which usually there are 8 wires inside or 4 pairs. and every two piece or one pair, they are twisted. You can search why they need to be twisted together. Twisting could be shielded or can be unshielded. So we have UTP, STP, so you can search by yourself to understand more the difference. So one can be more robust under noise, the one have shield, so therefore they can be for longer distance as well. Unshielded, they are they receive noise easier, so they are for shorter distances. Other communication media are free space. So you can see these antennas, they do microwave, or some of these are for maybe cellular communications. So you have satellite communication. In satellite communication, there could be microwave or they could be light as well. I can just see this. There is a light sending from between two satellites. But of course they are, they need to be line of sight so they can see each other. We have optical communication and optical, channels or optical fibers sending light from one part. We use a laser or LEDs to convert electrical signal to light, send to optical fiber, and in the other side there is a photodiode, receive the light signal and convert back to electrical signal. Mostly we have digital, digital communication in optical communication, most of them. So, okay, then what is after channel is a receiver. A receiver is what is a collection of electronic components and circuit that accepts the transmitted message from the channel and converts back into the standard format of what's supposed to be, which the receiver can understand or the user can understand. The user, as I said, could be a computer, could be a human. So that message, the receiver job is to convert back the message suitable for the receiver to understand. So if you are as a human, it should be voice, message. Otherwise, we don't understand if we want to hear. Or should be in the form of video. We can see on the television something suitable for our eyes. Or if it's in the computer should understand and convert it in the form of a text or voice or maybe video. So that there are some standard communication or methods between transmitter and receiver. So they have to have some standard form of established communication form. We cannot send something that the receiver cannot understand. Of course, then the message will be lost. This happened many times. You receive a file. The file is in a special format. The file come in full, package, but you cannot open the file because it's in a different format which you or your computer or your mobile do not understand what is the format, and then is meaningless for that receiver. It will be just nothing. So then you cannot open the message. Anyway, so the receivers also contain amplifiers oscillators, mixers, tune circuit, filter, and a demodulator sometimes, or demultiplexer, so to detect the signal and then convert back to original signal. Here also I show you just again, this is not just a design, as I said, it's just something schematic for you to understand how simple could be a receiver. Here is something like a coil to receive your electromagnetic signal, is for AM, amplitude modulation. So this is amplitude demodulation or demodulator. And then there are simple electronic circuits, and then there is a speaker to convert the signal to voice. So this is just for your understanding I show here. Don't use this as a design. And in many cases, transmitter and receiver are all together in one package. So nowadays, everybody have a mobile. So that mobile, I just show you the very old mobile here, because that was very popular and important some days. And I remember it was very exciting when I received my first mobile. And yeah, that is, we call it transceiver. Transceiver is something which have both transmitter and receiver in one package. So nowadays, our computer, our mobiles, they are transceiver. They can send and receive signal at the same time. I mean, they have both systems inside. So telephones, fax machines, and cell phones, computers, all those are, I mean, transceivers. So they have both transmitter and receiver inside. So in a communication system, we have attenuation, noise, unwanted signal. So just for your understanding, attenuation means, in fact, the signal power across along the communication channel will be slowly degraded, reduced. Is not suddenly, but is gradually. So when you send, for example, a specific amount of power at the transmitter side, of course, we do amplification. After amplification, we have a huge amount of power maybe, but when it goes from communication system, it slowly, the power will be degraded. So this is, we call it attenuation. In all communication system, attenuation exists. Only the amount of them is different from one channel to another channel. Many channels are frequency sensitive or selective. For example, if you send a message which contain high frequency and low frequency, depend on the channel, some frequencies could be degraded more than the other frequencies. For example, in electrical channels, high frequencies will be degraded much quicker than lower frequencies. Lower frequencies can survive more or longer distance. So, but high frequencies, they can degrade it very quickly. Here I just show you a comparison between copper cables and fiber cables, their attenuation in terms of distance. So if you refer to the y-axis is signal loss, and the x-axis is the distance. Here it just shows a meter, but nowadays we can go too long, even for copper cables, especially those twisted cables or coaxial cables. They can go, of course, more than 100 meters. But optical cables, talking about kilometers, so they can go to tens of kilometers before we need amplification or repeater. But for cables, copper cable, we need more frequently amplification and maybe regeneration. So you can see copper cable, they have much more attenuation compared to optical fiber cables. And in terms of frequency selective, I just give you a little bit explanation here. I assume you have passed a subject talking about Fourier transform and Fourier series. Have you? So when we show, for example, a signal like a rectangular form or digital form, this, if you decompose it or break the signal, it will be combination of multiple sinusoidal signals. In fact, all signals made of sinusoidal signals. Sinusoidal signals are our main or original signals. We always refer other signals to them. So, for example, to make a digital signal or rectangular form, we have different harmonics of sinusoidal signals, then superimpose them, combine them, then become like this rectangular form or digital form. So if you have first harmonic, third harmonic, fifth harmonic, your signal after superimposing these three become like this. If you want something very nice, digital signal like this figure A here, you need to have more harmonics, maybe 7 harmonics, 9 harmonics, 11, and maybe some more. So if you go higher harmonics, means your frequency is increasing. The first harmonic is, we call it fundamental frequency. Then third harmonic is 3 times of frequency of your fundamental frequency. Fifth harmonic is 5 times in terms of frequency. So means they are in higher frequency. Fourier series is a technique, mathematical method. We can break the signals in different harmonics mathematically to show them. So let me turn on my power supply. Okay, so then that is when we have one signal, we show you like a digital signal. Inside there are different frequency components. If you want to show mathematically, you need to refer to your Fourier series to understand this. So Fourier transform also can show you what type of frequencies exist there. but is a little bit different with Fourier series. Yeah, when you send this in your channel, higher frequency elements loss or degrade more quickly. Then your signal become rounded. If you see now, is more similar to like sinusoidal form after your digital signal pass through a channel, become rounded, means higher frequencies is just lost. So this is similar to low pass filtering. So means low pass filtering means low pass means low frequencies element can pass, high frequency component will be lost. So that's why we say most of communication systems are similar to low pass filters. So low frequency element can pass well, high frequency component loss or attenuate quickly. So yeah, that is what I wanted to show you and combine for your background to understand. So, okay, so noise is something always exists as long as there is electrons moving, noise exists. In all electronics, noise is something can be avoided. And noise is vibration of electrons. Heat can help to increase the noise. So is a random, undesirable electronic energy that enters the communication system via the communication media, and in the is like a interference as well, will be combined with your transmitted message. So most of the noises are in high frequencies, means they have fast vibration. If that frequency is different with your frequency, we can use some filters to filter them out. So for example, let's say noise is much higher frequency than your message. We can use a low pass filter, the signal pass, noise will be disappeared. But sometimes the noise is maybe same frequency as your signal or communication signal, then it's very hard to remove it. So some noise can be filtered out by filtering. Some of them we can use, some devices can produce low noise, minimum noise, and we can operate them in low frequency, low temperature to reduce the noise as well. So usually noise power, noise and signal power, when we want to measure, we measure together. So otherwise no meaning. If you say noise level is this much, people ask what is the signal power? If the signal power is good enough compared to noise level, is fine. There are some certain level for the receiver or detector to detect your signal correctly without error. We have some standard or form of signal to noise ratio level. So signal to noise ratio means signal level to noise level. So we call it signal to noise ratio. Usually it shows in decibel form. The more the power, signal to noise ratio, the better. Means signal power is more than noise power. So, but usually these values are very small. So the receivers of communication systems, usually they can detect very low power, signal to noise ratio. Still they can work and detect the signal. I would say they are quite advanced today. So okay, our channels can be simplex, means one way, one direction, or two directional. We call it full duplex, or two ways. Is like roads. There are some roads only one direction. There is no return. But most of the roads are two ways these days, like highways. On the other hand, we have analog and digital signals as well. So let's see what they are. Simplex, as we said, is one directional. So there is no two ways. For example, radio. You can listen radio, but you cannot send back a signal to the transmitter. If, for example, any issue you have, you cannot directly communicate with your mobile, radio transmitter to talk to. You need to use another channel to talk to them. Television, you can only receive. You don't have chance to send something. So many other things could be one direction only. So you cannot send back using the same channel. If you want, you need to use another channel. For example, this is television system. There is a channel, there is an antenna or satellite. They send broadcasting signal to everywhere. So if you have a suitable antenna or receiver, you can receive that signal. But if you don't have, the signal may be around you, available. Only you don't have a right receiver to receive it. For example, if you don't have a television at home, doesn't mean there is no TV broadcasting in your area. Maybe exist. You don't have something to receive them. If you have an antenna on television, you may also receive. So those are one directional, or sometimes the signal we send to our machines, like for example, here is a drone, or can be a toys controlling system, or maybe your remote control. Those are one directional. From one side, you send to another. There is no other way around. So we call it simplex. Means the communication channel designed for one directional only. So on the other hand, full duplex means two ways. So the communication is designed for both sides, transmission for both sides, both directions. So both users can send something. If both users can send simultaneously, we refer to full duplex. So similar to our mobile. So you can talk at the same time when you are talking to someone, at the same time when your other party are talking to you. You don't need to stop. Of course, if both of you talk at the same time, you may have, the two voice could be mixed together and you may not hear very well, but you are allowed to do this. You can do it. There is no any problem. So for example, now I am talking to you. You can at the same time talk to me with this channel because they are full duplex. So half duplex is a system that doesn't allow two parties to talk simultaneously, but they can do one by one. You talk first, then you stop, the other party can talk. This is not only between human to human, could be between two devices. So, for example, in military, many of them are one directional. Is half duplex. They talk first, stop, the other party talk then. So some family radios, some other maybe old communication systems, there was only half duplex. But something which is our daily usage, we don't have very common these days. So here is showing a schematic for full duplex and half duplex. In full duplex, your earphone and microphone, both of them have their separate channels with two different frequencies. They never interfere to each other. So while you are listening, you can at the same time speak. They go with two different frequencies and they can go through the channel. The other side at the same time as well. But in the half duplex, there is only one channel. This channel can only accommodate either your, for example, microphone or a speaker. If you are listening means the signal coming, you can't talk. So when the other parties stop sending signal means there is nothing come to your speaker, then you can, then you can use your microphone to send something. There is only one communication channel. If there are both of them, they will just mix to each other and maybe either the signal lost or unknown. So then you can't understand what's happening, or your signal won't be sent. So I guess you have had some time when you talk to very far distance, maybe both channels may not working at the same time. They have some delay. Doesn't mean they are half duplex. No, they are full duplex. But due to delay, due to the latency of communication system, you may hear in different time. You talk, then later you can listen. So there are some delay. Is some form of half duplex, but they are not really half duplex. They are full duplex, but due to delay, you have delay in hearing. You talk something, it will go a little bit late to your other party, then they will talk to you. You need to be slow. You can't be very quick. Otherwise, when you ask something, you say, hello, how are you? The hello goes first. The how are you may go a little bit later. And from the other side, the response of hello comes. And then, so that's why you may have mismatch of the voice coming. So you may ask a question 1 second earlier, but the answer come a little bit later. So sometimes it's happening in far distance. especially if the communication system are not very perfect. So, okay. In the other categories, we talk about analog and digital systems. So analog signals are like sine wave, voice. I am talking now, voice. I may stop at different time, but is still analog. So, and it is like a continuous analog signal. So video also is analog. Analog means there is no specific shape. It change based on the power of your voice and depend on different words have different frequency as well, different strength, so the level. Here is, for example, one analog signal. Sine wave is one analog signal. So our voice is analog, noise is analog. So here is showing sine wave, voice, and videos as analog examples. Digital signals, on the other hand, they have a fixed level over a certain period. Then they have another level in another period of time. So changes in steps or in discrete manner. So most digital signals use binary or two-state of coding. For example, telegraph, continuous wave coding also can be considered as this. Serial binary codes. So examples of them are here. For example, the top one is telegraph or Morse code. Our computer also could generate something similar to this, which you can see in figure C is binary. So this binary is maybe very similar to the one figure A, but they have different meaning. Depend on the time interval, they can have different meaning. For example, in the binary form, let's say we have certain time period for one bit. Let's say we refer bit as 0 and 1. I guess you understand. So 1 have a certain time. If you are sending 2, 1 next to each other, of course, your message will be longer. Receiver should understand this is 2, bits. They have taking sample at same frequency as your transmitter. So that's why they can understand this is 2 bits or this is 2 zeros. We could also have higher frequency, but in the digital form. For example, if you look at here, there is a high frequency wave sending, but they are sending at a certain time. So there are some signal going on, then there is no high frequency. It's like ideal. Then there is some signal, then nothing. Some signal, then nothing. So at the receiver side, they're receiving this frequency wave, or call it continuous wave, but in the digital form, means there is some certain time, some signal, no signal, signal, no signal. It's like a on-off format. Okay. Let me do 2 more slides, then we can go for a short break and continue after break. Okay, so digital signals in many transmissions are of signals that originate in digital form but must be converted to analog form to match the transmission system. Digital data over the telephone network. So, we can send digital signal in telephone system. Telephone is in fact mainly analog, but we can send a digital, let's say, computer signal, we can send in telephone system. But we need to convert them maybe to analog. Otherwise, it's not possible to be sent in that channel. So we also have analog signals. They are first digitized with an analog to digital converter. Then you can use analog to send in digital system. So if your system is digital, you have analog, you convert the analog to digital first. The data can then be transmitted and processed by computer and other digital circuits. For example, in our computer, you have voice, you have video, they are analog, but the nature of them analog. But when you want to save in the computer, you have to convert them in digital form, in binary form. But later when you are extracting them, or you are listening to a music or seeing a video, they convert back to analog form. Here is just one example. Having an analog signal, we want to convert these to digital. So, and in digital, you have certain level of digitization. So, for example, you have 0 volts, let's say, 0.125 volts, 0.25 volts, 0.375, and so on. If you do sampling at some intervals with some clocking, and if your signal, the level, amplitude, is below to the middle of a level, for example, from 0 to 125, 0.125, if your message or sample is below to the middle, you consider it as the lower boundary. If is towards the higher part, it considered to the higher part. Let's say here, the message is a little bit, the green one is the actual sampling, the value. The red point means the digitization level. So let's say the first one is at 0.001. Here the signal is a little bit more than 0.125, but we taken as 0.125. 0.125, this voltage shown by a binary value which is 0, 0, 1. The second sample is below 50% of 0.125, which is less than 0.0625. Then we consider as 0, and shown by 3-digit binary 000. The next digit is between 0.0625 and between 0.125. We consider as 0.125, then converted to 001. Yeah, of course, there are some errors in doing the digitization, and that error is designed to be acceptable. So the levels are designed which could be acceptable in system. So yeah, that is, we can stop here first. Then after break, we continue on our next topic.